अभी चालू किया है।
जल्दी से रिकॉर्डिंग
ऑटोमेटिक रिकॉर्डिंग होता है। अभी चार बात कीजिए सर।
हेलो प्रोफेसर केतन। बोल सर।
हो गए सर।
गुड गुड। तो म्यूट कैसे करते हो? फिर मैं अनम्यूट कर रहा हूँ। Good evening, Benet sir.
Sir, very good evening.
Good evening, good evening. So, how are you?
Good, sir. How are you, sir?
Good, good. I think you are all well prepared for online sessions.
Yeah, sure. What time we'll start, sir? 6 o'clock, or I will wait for some more time?
We'll start at 6 o'clock, sir. Because that they have got timing, sir. This is by Government of India, like All India Council for Technical Education. Na? This
Yeah.
is like sponsored by Government of India only. So they have time limit from 6 to 7:30, and next session 7:30 to 9. So, and we have to put this recordings on our YouTube and share the link with them.
Oh, okay,
Anybody can
okay,
watch it. This is on public domain because it is done through public resources. It is to be
okay,
put in public domain. Anybody can watch. So
okay, okay,
it
okay.
is, and at the outset, I'm thankful to you that you accepted our invite to be a speaker. And
Yeah, it will be always a pleasure to work with you. Also, we
like
are
good, good.
again in the same platform, multiple cases,
Yes,
right?
yes, yes. You host most of the time. This time I'm hosting it. From seeing you are hosting.
Yeah, that's true. That's true.
Monthly. Good, good. So you have one more session, no, sir? Next, I think it's
Yeah, 19th one more session is there.
that
Yes.
is good, good, good. So we have actually these are all faculty members, sir. We have almost
Okay.
uh, uh, yesterday I saw 150, 160 count was there. So we
Oh,
have
okay.
all faculty members right from Jammu Kashmir to Tamil Nadu, West Bengal to Mumbai. Everybody is there, and from different domains like mathematics, science, engineering. I think they have shown a lot of interest. People
Okay, okay.
voluntarily they have like applied for this because I think green technology everybody understands is very essential now.
Yeah,
Uh,
yeah, that's true.
India as a
There's a
nation,
lot of interest from the people.
a lot of interest. I'm very happy to see that actually. And they are spending time and they are even giving a lot of good very excellent feedback. What I have seen yesterday, two
Okay, okay.
talks. So people are really interested. They are learning and they are benefited out of these uh, initiatives. So it is a good
Yeah,
thing which is happening, and we are able to connect to hundreds of people. Yeah,
yes,
at the comforts of their home or office, they can attend. So this is an added advantage basically.
yes, 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 yes.
So today, you are speaking on net zero.
Yes. So
Actually,
we,
net zero, I am very sure nobody knows about net zero. Net zero means we think everything will become zero only. So,
no, no, no. There will be lot of experts from this team itself who are participants, and I am happy to. I am also eagerly waiting to get some insight from them also.
but actually, as a matter of principle, because what I have seen, sir, even yesterday we had some issue like people they by accidentally they put on their audio and then there is a disturbance.
Okay, okay,
So as a matter of principle, we have muted everybody and we are encouraging them to ask question in the chat box.
okay, okay, okay.
So after you wind up your talk, one of us will read out the comments so that you can answer it to the
It-
benefit of all. Like if you make unmute, then everybody will start speaking and there will be chaos basically. What we have seen yesterday.
yeah, some cases people may be traveling and attending.
Ha,
Background noise will be a challenge.
correct, correct, correct. Provide that kind of thing. Let us see. But they still have options to unmute themselves.
Okay, okay. So it's at 6 o'clock. Maybe you can suggest what time we can start. I am ready to.
1 minute. I think Shivani madam,
Yes, sir.
you please put a message in the WhatsApp group that it is starting.
Yeah,
Please join.
already I have put, sir. I'll just
And I think you make it a point that the attendance should be posted in this chat only. You cannot put it from today onwards. Don't post the attendance in the WhatsApp
okay.
because if somebody is not attending this and he is just filling the attendance on the WhatsApp, then it
Yes,
doesn't
sir.
make sense, na? So
Yeah,
you say that the attendance invariably will be in the session at the end of fag, and after each session the WhatsApp link will be opened and it will be given for some half an hour.
Okay, sir.
And today we'll the day we'll close that 9:30 we'll close down that accepting the responses.
Yes, sir.
Please make that clear to all the faculty members.
Okay, okay. So it's 59, in 5 minutes, I think all will join. Six.
So I think at this I should stop collecting responses now. We have got 180 responses for day 1.
Yes, sir. We have to stop taking responses.
How you stop that?
For participants?
No, I opened that Google form because it is in my drive. How I stop accepting response?
You have to go into the settings, sir. Rathod sir is with you?
Mr. Ganesh Rathod,
Yeah.
please unmute yourself.
Yes, sir.
Where are you?
No.
Baba, how to this? Because I want to close this. We have already received 180 responses, so I don't want any more response.
Sir,
Sir, on the right,
Pardon?
sir, on the right hand side, you can see one toggle is on and off button will be there. So you just off it from that toggle.
accepting responses off कर दीजिए sir.
अच्छा इतना इजी है क्या? किधर है भाई वो? दिख नहीं रहा मेरे को कुछ.
Sir, 71 participants are there. Should we proceed?
responses tab ने हो गया लो गया था toggle button
ये लेते toggle. Responses तो बंद था. But there is no toggle here, boss. Get select destination, download responses, print all responses, delete all responses. Settings node. Make this call responses presentation defaults. I'm not getting that.
Exactly that, sir.
So we'll proceed. 76 participants have joined.
Okay, we can start.
Yes. Kiran madam?
Yes, ma'am. Good evening, all. It's a pleasure to introduce to you our today's guest speaker, Mr. Benet George, who is the founder and CEO of Bigita Energy Solutions and ESG Consulting and Advisory Firm headquartered in Bengaluru with over 21 years of expertise in energy efficiency, ESG consulting, ISO 50001 implementation, project management, and training. He has successfully executed more than 700 projects across 11 entries, a BE accredited energy auditor and certified energy manager, AEE USA. He is also among the only 4 CEMI trainers in India. Mr. George has served as a trainer, speaker, and consultant for numerous national and international programs and was honored with SEEM National Energy Management Award in 2023 for excellence in energy auditing. He holds an M.Tech in electrical engineering from NIT Calicut and has prior experience with Schneider Electric and Academia as an assistant professor. Now, I request to sir, please take over the mic and start the session.
Thank you, Professor Suresh Mane, as well as all the organizers. And a very good evening to everybody. and good evening all the participants who are joining from various parts of the country. And it will be a great pleasure to present in front of you as a faculty. And in fact, I was also sometime a college assistant professor. I worked in an engineering college. So always it is a pleasure to share what we learn and also to learn from the participants. So at the end, maybe there are some limitation due to number of participants at the same time. So what you can do is your questions or your comments, you can put it in the chat box. And whatever the questions, we'll try to take it at the end of the session. Since once we start the sessions, I will also go in the full screen mode. Then I may not be able to see your comments or chats in between. So at the end, we'll take these questions. And any feedback or anything we can discuss. And any of you, if you have some of the experience as well as your expertise, we can share that. So together we try to make the net zero emission, how we can progress as a country and what as an individual we can contribute. So in this session, we are trying to understand what is net zero emissions, various strategies, how we can do accounting of these emissions, and some of the case studies. And in fact, as an energy efficiency professional, we help organization to reduce their emissions, and also we help organization to account their emissions. So unless you measure it, how much is your emissions, you may not be able to finally put a strategy for reduction. So with that, probably with the I will put it into full screen mode, and maybe during this presentation I may switch off the video in case of any. And again, to the organizer, in case any network issue or if any disturbance in the sound as well as any video, please let me know, so that or if slide is not moving, any other issues. So thank you. Whether someone can confirm my screen is visible?
Yes, sir. Screen is visible and you are audible.
Yes, sir. Yes,
Very
sir.
good. Yeah. Thank you so much. So this is what we are trying to cover in this short session: background in the urgency of the climate action and defining net zero and what does it really mean. And also some of the cases we have two other words like net zero versus carbon neutral, clarifying the concept. Then a big picture how global emissions is happening and what about the increase in the emissions as a country and globally. And how we measure the emissions, the GHG protocol and scopes, then engineering for net zero, then India national commitment and progress, and some of the case studies. So this is the first question. So maybe people can put it in the chat box. Do you really think climate change is real? You can raise your hands. I can see the hands. How many of think okay, climate change is real? Since as an engineering faculty, I assume maybe many of you studied maybe in the last century started your studies. So in many of the cases we studied, if you are not doing enough actions to reduce the energy consumption or energy, especially in the petroleum products, we were telling that okay, the next generation will get affected. Your next generation will get affected. But what we are really seeing is it is not about the next generation, it is our own survival. So what you see every day, so this is some of the case studies which is reporting every day. If you see in the very recently, we have many of the issues in the Himalayan, and last year there are a lot of fire in US. And if you see every year number of incident, extreme weather events are increasing and everybody is getting affected. Some of the cases people were thinking, okay, this climate change will affect people who are staying near to the seashore because of the increase in the water level. And some cases, people are thinking, okay, it will affect the people who are living in the hilly region. Some cases, people were thinking, okay, we are affluent people, we have enough money, we may be able to manage. So, but in the real scenario and recent events, all proves whatever that thinking is wrong, and everyone is vulnerable, and everyone may affect with climate disaster. So the decisions what we make today will define livability of tomorrow. It is very clear. So we have not enough time to sleep, but it is quite delayed, and it is we are the people who take the actions. So what the previous president of United States told is, we are the first generation to feel the effect of climate change and the last generation who can do something about it. So that means if we are not doing enough actions, it may be quite difficult for the next generation to see the same climate. So it is really a climatic emergency, and we are supposed to take the actions. And again, the urgency is not simply talking, it is based on the science. And global warming is already at approximately 1.2 degrees Celsius above the pre-industrial levels. Climate impacts are accelerating, time is limited, engineering innovation and policy play a central role. That is what we see from all over the world. And it is quite evident that the increase in the emissions, global emissions, are mainly due to industrialization. And when industries produces various goods, even maybe some of the cases when they give some of the services, it requires a lot of energy, and that energy, many of the cases, it is coming from fossil fuels. Even if many cases, even if we are getting the green energy, including solar or even wind, for making that solar panels or wind turbines or the associated equipment, we need to take the resources, and extracting the resources and processing that resources and utilizing that resources to give products and services, we need energy, and which increases the CO2 emission. And when you see the numbers, there are approximately 75% increase in total GHG emissions from 1970 and 2004. And when we see that in absolute numbers, for example, CO2 emissions for fossil fuels and industry in 1750 was approximately 0.01 gigatons of CO2 to approximately 37 gigatons of CO2 in 2022. So there's a huge increase. And in fact, as a country, or when you see the global scenario, it is quite difficult to control the usage of the energy. The reason is, if you see globally, many of the developing countries, including India, Africa, and many other countries, in the industrialization or the usage, energy intensity is quite low. Energy intensity is quite low and population is quite high. So it naturally demands more energy for their use, and which is also will get affected or increase the CO2 emissions. So this is the CO2 emissions country. Basically, you can see this is based on absolute numbers. So when you see in the lower level, 0 to 3 million ton, and when it comes to the countries, like from the color you can understand, okay, China is the most CO2 emitting country, followed by the US, and India stands something in between. So when we consider the India, and we may have to consider multiple aspects. One is the total emissions. We may also have to see what is the energy intensity or emission intensity. When we compare the emission intensity globally, US will stand first, and many other countries will be much, much lower than United States. In 2023, India emitted around 3.06 billion tons of CO2. So this is all published data. Why we are discussing this is the emissions are quite huge. The emissions are quite huge, and it is going. If we are not doing enough actions, the emissions and its effect will be multiplying. When you talk about multiplying, this graph clearly shows that what is the emissions from 1750 to 2023. For example, you can see that in 1900, in US and like many of the industrialization started, industry started producing various products, and due to that, the emissions started. Then many other countries, for example, India, you can see the line is quite in the bottom side. Even after our independence, our emissions were not very high. We were mostly an agricultural society, and we had some of the services or products. But when you see here in China, maybe last 25 or last 50 years, or maybe again when you see last 25 years, in the increase in emissions from China is quite huge. Now when we see that the absolute number, China in 2023, it was 11.9 billion tons. And especially as a educated or as educators, when you read the newspapers, you also see that our aspirations. You may be seeing even this week, we had many of new industries coming up. We have maybe semiconductor devices, many other industries. That means there is a high chance we follow the pattern of what China had done. So that means there's a quite increase in the emissions from India as well. And what is the impact of these all emissions? Is there an impact? So we've seen that impact. So basically, every degree Celsius, every 1 degree Celsius is quite matters. And for example, when the climate extremes, that means it can be heat waves, it can be floods, it can be droughts, or it can be cold waves. So this all, it is not only heat wave, it is not only floods. Even some of the cases, the cold wave is also worsening comparing to the pre-industrial levels. So now when temperature goes up, something like 1.5 to 2 degrees Celsius or 4 degrees Celsius, it become more frequent and intensity of this event will become more severe. Then limiting this global warming to 1.5 degrees Celsius, it is quite difficult. It is not very easy. It is quite difficult, but still, it significantly reduces the risk compared to higher warming scenario. So this is what every 0.1 degree matters in warming the world. So heat wave increases. So city with the 5 deadly heat waves a decade. Now you can see that, okay, one extra heat wave for every 20 years. Then for example, otherwise 0.1 degree Celsius rise is approximately 3.6 into 10 raised to 20 joules extra heat. That means there is a higher amount of water vaporize, and also in the melting of ice will happen. When water vaporize, it will go and finally it has to come down to air. So there can be a lot of heavy floods or cloud burst. That is what we see in very recent climatic events. And second part is, due to this climatic event, there's a lot of crop and yield reduction. So that means there is many cases sudden rain, otherwise extended drought, or there is a cold wave. This all increases in the reduction, the chances of reducing the agriculture products. And again, you can see the ocean temperature rise and sea level increases. So this is what it is happening. So 1850 to 1900, in the intensity of climatic events was maybe once in 50 years. Then it become every the once in 10 years, and then it become 2.8 times in present 1 degree Celsius. And if it is 1.5 times, it is maybe 4.1 times. And if it is 4 degrees Celsius, it is 9.4 times. That means it will be quite difficult us to live in this world without our affecting our normal activities. And this is about hot wave, and this is about the heavy precipitation. So heavy precipitation happens, and you can see it is happening. Even earlier people were thinking, okay, this will all happen near to the seashore. Now we are seeing, okay, in Bangalore or many other cities like Punjab or Himalayan regions, heavy rains that is really affecting the people. Why we are giving this much introduction on in the emissions? This is to really understand this is a emergency scenario, and we have to act. This is United Nations climate change visualization on various scenarios. 1.5 degrees Celsius scenario, that means we can manage the situation. That means if we are able to limit in the temperature rise in 1.5 degrees Celsius, we'll be able to manage. But in case it goes to, that means +2, that will be yellow, orange, or orange color. That means more heat and stress, and it will be much beyond. So in the present scenario, if the emissions increases, we may reach even +2 scenario. And in the red scenario will be quite difficult to live in the planet. Now we are coming to our exact topic, what is net zero? So net zero means the cutting carbon emission to small amount of residual emission that can be absorbed and durably stored by nature, and other carbon dioxide removal measures, leaving zero in the atmosphere. So by doing that, we preserve a livable planet, and we ensure that the limiting the temperature rise 1.5 degree above the pre-industrial limit. Then we also have to understand Earth is already 1.2 degrees Celsius. And considering all this, every country is understood, and they came into a Paris Agreement, and then came to 1.5 target. And they also tried to reduce the global emissions by 45% by 2030 and achieve net zero by 2050. And various countries taken different targets on net zero. We also taken a target, we'll come to that. Now, there's a difference between net zero and carbon neutrality. When carbon neutrality means achieved when emitted CO2 is balanced by offsetting. So that means you can consume whatever you want. Then either you purchase some of the certificates, or you maybe plant trees somewhere else. That means it is not really fully focusing on the actual reduction, but it is trying to offset. You do all the emissions, and you try to tell, okay, you balance that with some carbon credit, or you purchase the carbon credit from some other countries, and you are telling, okay, we are carbon neutral. But in that case, what is happening? You are not really avoiding the emissions. It is happening somewhere, and you are actually balancing. The picture shows that. But that is mostly on the CO2 emissions only. But in net zero also consider other greenhouse gas emissions like methane and other emissions. And it is how we are actually reducing. So in this case, we have to reduce first, and even after that, you may not be able to reduce 100%, and then use offset only for that remaining very small amount of residues. And this is aligned with the Paris Agreement. Because in the other case, in the first case, carbon neutrality, you are actually shifting from one location to other. But in the second case, you are actually reducing in the emissions. So again, carbon neutrality is balancing in the CO2 today, and it can be offset heavy. That is what we are seeing earlier, CDM mechanism, etc. So people or countries who had money, they invest in some of the project in other countries. It can be the forestation project or other projects in maybe in the developing countries, and they are trying to offset. But in net zero is permanent solution for all GHGs aligned to climate science. And then we have to understand when you are trying, okay, net zero, we have to understand where the energy is consumed and what is the uh, the pattern and how it is used across various sectors. This is very, maybe you can say it is self-explanatory. In the energy consumption, the emission to energy accounts 73.2%. Out of that, energy used by industry comes around 24%. And you can see iron and steel. Iron and steel comes 7.2%. Chemical and petrochemical comes 3.6%. So basically, when you construct a new buildings, of course, the new buildings infrastructure, we need more iron and steel. Now that accounts around 7.2%, and chemical, petrochemicals 3.6%, food tobacco 1%, paper pulp 0.6, machinery 0.5%, and other industries comes around 36%. And transportation comes around 16.2. Out of that, road transport comes 11.9%, and aviation comes 1.9, shipping comes 1.7, rail, pipeline, etc. 0.4%. Then energy usage in buildings 17.5%, out of commercial is 6.6%. Then residential buildings 10.9%. Now, when you think all of us are part of this whole consumption, including iron and steel, or it may be the transportation, it may be the buildings. We use buildings, we have vehicles, as well as we use all the resources. So we are also equally responsible in these emissions. Then other cases like unallocated fuel consumption, combustion, then fugitive emissions from energy production. For example, when you are producing the energy, you have emissions. Then other industries, for example, when cement manufacturing, you know that, okay, when clinkerization happens, it produces CO2 in the chemical process. And other chemicals, wastewater, you have methane, landfills 1.9%. Then agriculture and forestry land use also comes quite huge. That means it is 18.4%. Of that, livestock and manure comes 5.8%. So, and this also gives an opportunity when you see that even we think in quite basic level, we can see that there are a lot of opportunities, and you may be able to see that in your surrounding. For example, in transport, we may be trying to reduce the emission, maybe switching to solar, even the electric vehicle, which may be charging using solar power. And industry, we have so many policies which may demanding the industries to consume less. And building energy conservation codes and other mandatory requirement to reduce the energy consumption. You can see here, this is the energy consumption increases like in various sectors, transportation, energy, etc. Now, when countries made an agreement to limit the emission or trying to limit the heating by 1.5 degree, then there is a guidelines and framework by various government organizations or government And in India also, we have, when we are also part of uh, this agreement, we are also as a country doing many of the activities. We have National Action Plan on Climate Change, NAPCC, renewable energy, and hydrogen missions. And under NAPCC, we have National uh, Enhanced Energy Efficiency Mission. Then we have a PAT scheme. PAT scheme is for large industries, especially steel, cement, petrochemical, paper, this type of industries. When you see these industries, for example, the PAT scheme 1, around 452 industries were involved, and it was a given target. So every 3 years, they have to reduce the energy consumption, energy intensity, basically, 3%, 5%. That means even if in the industries are paying, government given a target to reduce their energy intensity. Then we have Ujala scheme, like the LED lamp scheme, then energy consumption building code. These all are the some of the programs by Indian government. Then these are the Kyoto Protocol. There are binding targets. So industrialist countries to reduce GHG emissions by 5%. Madam, can you switch off your? Then it also gives flexibility mechanism. That means emission trading, clean development mechanism, joint implementation for cost-effective reduction. So in that case, like you thank you. Then monitoring and reporting, and it is mandatory to report every country's emissions who are part of this Kyoto Protocol. And this was the roadmap. In 2015, 196 countries adopted the Paris Agreement to reduce global warming. 2017, countries submitted a climate action plans, that is NDCs. That means national declared climatic actions. So that means every country, whatever they are planning to do, they given. So in 2020, ahead of COP26, countries are updating NDCs with urgent actions to cut emissions and achieve net zero by 2050. And 2023, to limit the warming to 1.5 degrees Celsius, emissions must drop greater than or equal to 45% from 2010 levels. That is the again, and every time what is happening when emissions are not really coming down, countries are trying to put some of the targets. And then in 2050, the transition to net zero must be fully achieved. So this is the target or roadmap in general, various countries level. And in Indian scenario, in COP27, our Prime Minister announced in November 2021 India's net zero commitment that is called Panchamrit goals. That is the 5 goals. In that goals, basically it is a multi-dimensional approach. We are committed as a country. By 2070, India will reach net zero greenhouse gas emissions by 2070. So it may be after the global target. And by 2030, non-fossil energy capacity increased by 500 gigawatt by 2030. And the renewable energy share. So there is a two, the second and third one. Second one is fossil fuel energy capacity, that's a power capacity. And third one is in terms of energy share, there's a difference. One is a capacity basis, second is the energy level. Mean 50% of its energy requirement from renewable or non-fossil sources by 2030. So basically, when you see in Indian scenario, we have a lot of non-renewable energy like solar panels in gigawatt range. But even though our capacity is high, in the generation is only during the favorable time, like the daytime, and that also variable. So even now, in the total the non-renewable energy, the renewable energy sources, energy what in absolute term is we use, it is much lesser than or maybe 10 to 15% still now. And emission intensity reduction is reduce the emissions intensity of its GDP by 45% from 2005 levels by 2030. In this, we are trying to reduce the emissions. For example, if you may see various program emission reductions for industries, maybe you may see star labeling. These all are part of the emission reduction strategies. Then we are also having a national hydrogen mission by 2030, reduce the projected total emissions by 1 billion tons of CO2 by using this mission. Now, where are we now? So there are a lot of progress we achieved, and this is the data. Maybe this is from June 2025. So this is the installed capacity. We have a target of 500 gigawatt by 2030. Now we are around 227 gigawatt. Out of solar comes 110.9 and followed by hydro 20.48 gigawatt. Sorry, wind power is second, that is a 51.3. Third is hydropower, then biopower, nuclear, and small hydropower. So this data is from Ministry of Power. There is a progress in the renewable energy. Then other cases, we have policies are there, policy implementation is ongoing, and various actions are taken by the government bodies. So there are some of the pilot project or technology requirement is there. For example, after reducing the emission, there is still, see for example, we have still many of the industries, say steel industry or cement industry, which produces CO2 emissions in their process, which is unavoidable. Now, what we have to do is people are trying to capture that CO2 and store maybe underground so that it is not going to atmosphere and it is not going to the emissions or sorry, the increase in the temperature. So that type of technologies are trying. There are a lot of technical challenges. One maybe it involves a lot of cost and the space requirement, but it and many of the technologies are in very early stages. And second, maybe one of the programs successfully running is in the EV program, EV vehicles. You can see there are a lot of push for the EV programs. It can be EV private vehicles or the public transport. And you can see almost a complete railway is electrified and mass metros, developing of mass metros. This is all part of the development, and also it will help to reduce the emissions and to achieve our target. So when you see that as country level, there are some of the programs. Now, how will we really do this? So one part is we have to first understand how much emissions are there due to our activities. That is basically the calculation of the emissions from various activities. Second, wherever possible, we avoid and reduce. At the end, try to offset. For example, we've seen that there are industries, transportation, building. We can take these three examples. Now, it is quite possible to calculate the emissions, including embodied energy. Embodied energy means when we are constructing a building, what is the energy that is there? It may be the usage of the cement or usage of the bricks or the other material, how much energy is there. And it is also, we can calculate what is operational energy. And now people are trying to use the material that having less embodied energy. So that means we are trying to reduce the energy during the construction. Second, people are trying to reduce their emissions during the operation by using efficient equipment. It is also some part is mandatory or it is regulatory. For example, energy conservation building code that demand the building having more than 100 kilowatts should have a minimum efficiency requirement. Then there are some voluntary mechanisms like star labeling of the building, or there are other programs like green building certification. This all will help in directly and indirectly the emission reductions during construction as well as the operation of the building. And when you see the industrial section, there are a lot of emphasis given under PAT scheme, that is perform, achieve and trade, where industries were given target, majorly the large industries based on their emissions. Now, from this year, earlier it was only the emissions based on the energy. Now from this year, it is completely based on all GHG emissions. That means including process emissions are going to add. And then they'll give a target for emission reduction. That is called in a CCTS mechanism. So there are programs running for reducing these emissions. And there are a accelerated program for EV vehicles. Then for measuring the GHG emissions, to everybody measures the emissions in the same pattern. So there is a protocol called GHG emission protocol. And based on that, it's an international standard for measuring and managing GHG emissions and under IPCC. So it gives various categories. There are 3 categories or scopes of the emission based on their source. So why we have these 1, 2, 3 categories? It helps organizations and people to do mapping of their emissions based on this category. And once they go mature, for example, it may be quite easy to get the data of scope 1, 2 emissions, and scope 3 emissions maybe gradually they can collect. So in GHG emission, as per GHG protocol, it consider all the gases, not only CO2, but also CH4, N2O, HFCs, SFCs, NF3 and PFCs. Now all these gases is converted into an equivalent CO2. So that means at the end, it will be tons of CO2. That means other gases also converted into CO2 equivalent based on the global warming potential. And in scope 1, emission is direct emission. That means companies' facility, what are the emissions comes. For example, if somebody is operating a gas oven, due to combustion of that gas, there are some emissions. So that is added in the scope 1 emissions. Or someone is using an air conditioner in their facility. In air conditioner, we use some of HFCs as a refrigerant. Due to usage of that refrigerant, there are some emissions. Or they have vehicles, company owned vehicles, then due to that, there is emission. This all comes under scope 1 emissions. And this may be quite easy to, some of the emissions we can easy to calculate, some are quite tough. There are methodologies, and some of the cases, if you burn a specific amount of fuel, how much emissions is coming, this data is available. Then a scope 2 emission, basically what will happen, somebody purchases energy from the grid. In the emission may be happening somewhere far away in a thermal power plant, they burn coal and it causes the emission. Now, based on the type of energy, there is a multiplication factor, and we had to account that emissions in our emissions. So that is one thing. Then second, some of the cases, it may be not very common in India, purchased heating and cooling. For example, it is mainly applicable in large cities. For example, in India, Gift city in Gujarat, they have centralized chillers. Centralized chillers produces the cooled water or chilled water, and individual facilities will get the chilled water, and they were given and they are built based on their energy consumed, or the emission BTU, how much BTU they consume, or the steam purchase. This all will come into scope 2. So it is quite simple. For example, if you consider a domestic case, whatever electricity we purchase, we get a multiplication from Central Electricity Regulatory Authority. They publish a emission factor based on the mix of energy produced in India. They put a factor. So this is available in a CEA every year. They'll publish, and we can use that data, and from we can multiply. And the first one, if you have a vehicle, you can also use how much diesel is consumed based on that. Then scope 3 is quite complicated. There are two parts. One is upstream. Upstream means you have leased asset. You may not be owning the asset. For example, you may have leased vehicles. And the second is employee commuting, it coming to the office. Then purchased goods and services. We may be purchasing a laptop, which is using in our office. But for producing that laptop, there is some CO2 emissions. We have to account that too also. Then business travel for various mode. It can be flight or various mode. Then waste. So if you generate some of the waste, due to that, the methane gas can come, or for disposing that, how much energy is required. Then other is fuel and energy, transport, distribution, capital goods. So this all will come in upstream activities. Then downstream activities, for example, somebody is producing a material. Okay, somebody is manufacturing some food product, packaged food product. Once it is go out from their boundary to reach to the customer, there is some transportation distribution. So there is a fuel consumption. And then once they supply to the people, they may be using some energy for cooking, or somebody is using for, if other product, maybe there may be some energy consumption for usage of that. Then usage of sold product. You are purchasing a TV, but using a TV, we are consuming electricity. Then leased facilities, investment. For example, you are a banker and you are investing, or a investment banker who is investing in some of the company which uses some of the equipment. Due to that, some energy has to account in that the person who is investing. Then franchises. Then at the end of the life treatment, for example, final disposal, how much energy. It is not when you're disposing, what is the energy. So once you add all this together, it will give the complete visibility of what is the emissions by individual organization. Then again, when you do this GHG accounting calculation, we have to remember there's a protocol standard, ISO standard 14064. Based on that, we can do the accounting, GHG accounting, based on the GHG protocol. It should be relevance, completeness, consistency, accuracy, and transparency. So for example, if at the end, all the organization want to show the reduction of their emissions. So it has to be ensured that if somebody is consider like a particular part is part of their emissions, the next year also we have to consider that in their part. So otherwise, what will happen? To give an example, somebody is doing some activity in a factory. You can consider automobile industry. They are making some component in the factory, but then they're disclosing that since for producing that they are consuming some energy. Next year, if they outsource that into one smaller supplier, and then some of the companies may not show that into their account, and they only disclose okay emission 1 and 2, scope 1 and 2. So that is not a right way of representation. Then accuracy, transparency. This is the principles, and basically the calculation is based on what is the activity data. So how much liters of fuel consumed, how much kWh of energy is consumed. There is an emission factor. Then some cases, okay, you are using some of the refrigerant. Then emission factor into global warming potential, we have to multiply, and we will get CO2 equivalent. At the end, this is the GWP. For carbon dioxide, it is 1, methane 28, nitrous oxide 265, hydrofluorocarbons 138, perfluorocarbons 6630, sulfur hexafluoride, which is using in electric circuit breakers, etc. So you can see it is quite huge, 23,900. That is why in case some of the factories, if they have SFC circuit breakers, you may have high chance of emissions. So this is again little different way of representation to make it clear. Scope 1, direct sources owned and controlled by company, transportation vehicle, and owned and controlled vehicle like factory, then natural gas, this all uses, all the type of uses, and burning of fuels. Then process emissions from the, for example, a cement factory, the CO2 emission from their process, that is comes under scope 1 emissions. Then fugitive emissions like leaks of unintended gas leaks from equipment, refrigerators, pipelines, mining, this all comes under scope 1 emissions. Or methane leak from the pipelines. So this also comes under scope 1 emissions. And oil and gas, direct emission from extractions, refining, processing fossil fuels, combustion emissions, then transportation, CO2 emissions from combustion of gasoline, diesel, and jet fuel. This all comes under that. Then manufacturing, in various sectors, when you see that, we can understand that, okay, this will come under scope 1 emission. In some of the cases, it can be done. Now, even how we'll calculate that? So this is an example. A cement manufacturing plant emits CO2 during calcination of limestone, CaCO2, to produce clinker. During the year, plant consumes 10,000 metric tons of limestone, and the chemical reaction releases 0.44 metric tons of CO2 per ton of limestone. Calculate total CO2 emissions in this process. So we know that what is the activity? The activity is calcination of CaCO3 and activity data. So the 10,000 tons of limestone is converted into clinker. Then emission factor, every ton it produces 0.44 tons of CO2. So total emissions is 4,400 tons of emissions. So for a cement plant. Then another example, this is actually from the leakage. A manufacturing plant uses refrigeration equipment that contains 100 kg of R22 chlorodifluoromethane as a refrigerant. During the year, 15% of refrigerant was lost due to leak. Calculated the total CO2 emissions from these leaks given the following data. GWP, global warming potential, comparing to CO2, R22 is 1810. So you may think that, okay, how will you find out the leakage in a facility? You, as an engineering college, in your college also probably there may be number of air conditioners. How will you calculate the leakage? It may be very minute. So typically what will happen in when the gas leaks, the performance of air conditioner will go down. Then you may call the service person and you'll ask to refill the gas or refrigerant. Then for example, that data you will have, okay, in a year you done refilling of 5 refrigerators, or air conditioner, and you used to say 2-3 kgs of refrigerant. So you have the data, how much refrigerant you use for that particular year. Then once you multiply that, you get how much is the CO2 emission, since it is given the CO2 emissions multiplication factors. So this is how we'll account the emissions. So if someone wants to like to know a little more, you can go to JJ protocol and you can get this data. This is about scope 1. Then scope 2 is nothing but in the purchased energy or purchased electricity, or it can be the purchased steam or purchased cooling. So a manufacturing facility consumed 12 lakh units of kWh of electricity in a year, and emission factor for purchased electricity from the grid is 0.85 kilogram of CO2 per kWh. Calculate the total CO2 emissions from electricity consumption. So electricity consumption is given 12 lakh, then multiplication factor is given. Then you got how many kgs of CO2. And finally, typically the reporting is in tons of CO2, so you have to convert that into tons of CO2. Now, if you see in your organization, you are going to calculate what is the scope 1 and scope 2. You can do adding up these two emissions, and you may have some other emissions also, what as seen in the previous cases. You can add up and you can declare this is the emissions that was there in our organization in the previous year. So we have to also remember that the accuracy of the data and transparency is important. When you are telling what are the data we publish or add in the calculation, it should have basically a source of data is mandatory. So basically that is why it has to, verification is mandatory when you disclose to the public domain. So this is the how you measure and report the emissions. Then how you reduce the emissions. So basically emission reduction is something you can enhance the energy efficiency. For example, you are using scope 2 emissions from the energy consumption. That means when you reduce the absolute energy consumption, you are going to reduce the emissions. To reduce the absolute energy consumption, to do the same work, either you have to improve the efficiency of your equipment or system. To give a simple example, replacing a conventional lamp with a LED lamp, you get equal or better illumination by using the lesser energy. So that is one way of improving the efficiency. So which in fact reduces energy consumption. Or for a pumping system, you use a better efficient pumping system. Or if you use a better high efficiency motor, it reduces the energy consumption. Second one, so that was for scope 2. In case, for example, upgrading machinery which is consuming, okay, you have a diesel generator set and you use that, this all will work out. Second case, replacing fossil fuels. Now, many of the cases, what will happen when we do especially the last 1 year or last 2 years time, many of the organization, they are shifting their, say, diesel fired or furnace oil fired boiler to biomass, or they are converting to electrical boiler, even though the investment is quite huge, because as an organization, they've taken some target to reduce their emissions. What is one thing they are trying to reduce? Then second, they are replacing the fossil fuel. So they are reducing the scope 1 emissions. Good example is replacing furnace oil with, say, biomass, the biomass briquette. Or some cases, people may replace a diesel-fired boiler with natural gas boiler, or replacing with an furnace oil boiler with electrical boiler, and which is taking power from solar or green sources. These are some of the examples. Same case, electrification of machinery mechanism, converting everything to electric. Again, we have to remember that converting to electric is directly won't reduce the emissions, but you have to also ensure that whatever you are consuming is from green sources. Then carbon capture and storage, we can say it is something like a last option because of the technological limitations and the investment. But CCS, carbon capturing and storage technologies, what it will do, it capture, see, for example, whatever the emission is there, it capture, and some of the technology, in simple terms, they make a drill a large hole deep into earth, and at high pressure, they pump this carbon dioxide to the earth, and it will be captured inside, and gradually it may convert into, similar to any carbon, it may convert into other carbon products, coal or maybe petroleum product in millions of years. Then in terms of industry, hard to abate. So it is some of the cases, it is quite difficult to reduce the emissions. Then people will go from changing one technology to other technology. So for example, arc furnace in the steel industry. These are some of the options. So this is, you can see here, it is a carbon capture, utilization, storage. Like CO2, recently, to give an example, recently we done an audit in basically they have a sugar factory. From the sugar, molasses will come. That molasses, they produces the ethanol. ethanol will go to vehicle for blending. During this process, like fermentation process, you know that CO2 will come. So whatever the CO2 comes, they capture that CO2 and that CO2 will go to other factories like for other like carbonated drinks and all other applications. And again, the waste, what they will do, they produces the methane, like biogas. They have huge biogas production, anaerobic production, and they clean that. That means in that gas they have CO2 and all. What they do, they completely clean and they compress, and finally they produce compressed natural gas. That will go to various like automobile industry. It will go there. Then in this process, final some product is there. Their waste material. When the molasses is there, it can be semi-liquid form. That will go to an incineration boiler where they'll burn that. From that, some of the CO2 it will go out. Definitely it will go out. But since finally when you see that these all are bio, the grown items like plant-based, so their overall emissions, when you see that, it is very minimum. And second is the same way the green hydrogen where you use solar power or wind power for producing the hydrogen. So that is also an efficient way of reducing the the carbon emissions. Then you also maybe seen that in the one of the previous figures, the waste is also producing a lot of emissions. One is due to the transport of that waste material, transport or processing that waste material, and the recycling, or some of the case it is go to landfill also. When especially when it is biological biomass goes to landfill, it produces methane, and methane is GWP is much higher than the CO2. So overall emissions will be high. So what people does is they are trying to reduce the emissions. For example, some of the cases you can see that instead of paper napkin, people are trying to use a blower to avoid the usage of paper. They're actually reducing the paper usage. And some of the cases, recycling or upcycling of material. So these all are some of the ways to reduce the emissions or to become the net zero. Then, as an engineering fraternity, we can also help in the net zero. One, in designing, okay, in energy efficient systems or even the building. So there are technologies available, but proper usage of that technology definitely reduces the carbon of buildings. Many of the cases 50% also. Then this is some of the insulation. For example, building insulation may be a cold country. By having a insulation, you may require lesser heating energy, and also it increases the comfort. Second, in the efficiency standard. Now, for example, we don't have a star labeling for vehicles, but we have efficiency standard for equipment. For example, now many of our equipment, like it may be the fans, it may be the refrigerator. In India, it cannot be sold without that star labeling. So that is also actually reducing the energy intensity. Then industrial upgradation, it may be automation, uh, etc. So which finally reduces the carbon emissions. Then we also have to understand the carbon credits and offset. So, sorry. So in this carbon offset, in some of the cases, by doing all this, so carbon capturing is not possible, even some of the cases. Then what they will do if somebody wants to become carbon neutral or the net zero emissions, then what they do is they may plant a number of trees. They calculate how much emission they are producing, and there are standards to offset that much emission. They may plant somewhere else this many number of trees, and they'll monitor, okay, this is whether live or it is growing. And based on that, they'll claim net emission is 0. That is carbon offset mechanism. Second case, even some of the companies or some of the organizations, for example, there are some of the programs, efficient cooking stove. Efficient cooking stove. Once in kitchen, people, especially the wood-fired stoves and all, there are highly efficient stoves, which actually reduces the emissions by more than 50%. What does is they will have the proper documentation mechanism and see that how many stoves are distributed, and based on that, how much total emissions could be reduced. And they have a verified data, and that is called, when you have a 1 tons equivalent of emission is achieved, you can say you have one certificate. So this is called a carbon credit, which you may be able to sell. So for example, some of the companies, they have already emissions. They try to reduce, and finally they are not able to do. What they do is they purchase the certificate from other people who are already done, exceeded their requirement, or they've done projects. It may be the forestry projects, or it may be a efficient cooking system. It may be other project. So by doing that, they maybe in the LED project. So these all are some of the opportunities which can get a carbon credit by showing that it is actually reducing energy consumption and the emissions that can be purchased. That is also one way. Then there is another term called carbon budget. Carbon budget is nothing but the maximum amount of carbon dioxide and other greenhouse gases that can be emitted in the atmosphere while keeping global warming within specified limit. So, for example, 1 degree Celsius, how much emissions can be done? That is called carbon budget. And it is also shown as a spending limit. You may be seeing that, okay, we exceeded that limit in advance. Every year we are exceeding. But which day we are exceeding, it is also becoming news. So then is it really companies who are really trying to reduce? And there are great examples even in our country. This is an example from Infosys put in 2011. It is not now. 2011, they committed to become carbon neutral by 2020. And they joined in global RE100 campaign. That means 100% renewable energy consumption by 2015. Then they also got UN Climate Action Award. Then they become carbon neutral 30 years ahead of the Paris Agreement. 2020, they become carbon neutral. Then they done some of the activities like first solar decathlon. What they done is they actually done a lot of investment in their infrastructure and lot of investment for measuring in the various aspects. For example, when we consider okay, infrastructure means there some of the campus is quite huge. It is in 50 megawatt or higher capacity campuses also. So they done analysis of the buildings, and based on that, whenever they build a new buildings, they incorporated many of the energy efficient technologies. So for example, even this data you can get from internet. They have installed some of the passive cooling system. They done the centralized monitoring. And by that, they reduce their emission intensity even 50% also. So what they've done is in 2024, they launched a platform. What they've done is other people can go and learn from this, and they can incorporate what is this various aspects of building energy reduction. And they also have, see, even this, we have to also understand, okay, carbon neutral and net zero is different. So to become net zero, what they've done is they initiated large-scale agroforestry project. So that means they invest in agroforestry and number of trees and how much carbon it can capture. Based on that and how much carbon it is emitted by the organization, they will do the offsetting of that. So they become the carbon net. Then Wipro, they have target is achieving the net zero emissions by 2040 with a near-term target of 55% reduction in GHG emissions by 2030. So these all are, you can see that there are a science-based target. When it is science-based target, we have to show that how it is going to achieve. There are protocols it is given. And then they have challenges. This also that it is not everything is not very easy. There are challenges. Then what their strategies is energy efficiency as a first strategy. Why that is a first strategy? In energy efficiency, you are actually reducing your emission intensity. You reduce maximum, then you avoid, then finally you are trying to offset the whatever is not able to achieve. And renewable energy, increasing consumption of renewable energy, they are also doubled from 28 in 2017 to 55% in 2022. Now, people who are working in the maybe in the ESG domain, you can also understand that there are BRSR reporting. It is mandatory reporting by the companies, listed companies. In that, they also have to declare how much emissions are there, what they've done, how much and the progress in emission reduction. This also has to declare in their annual return, which is published in and submitted to the regulatory bodies. It is mandatory. That means everyone is looking not only their financial returns, but also they're looking whether the organizations are doing enough to reduce their emission reduction. And globally, when you see that the sustainable companies are getting or doing better business comparing to a normal companies. So people are very much aware that the actions of the companies on reducing their emissions. So this is a typical steel industry case studies. Steel industry is one of hard to abate sector. That means you can see in the initial picture, 7% of global GHG emissions is primarily from the steel industry. And this is mainly coming from, in the process, they use coal. It is a process requirement also. In the blast furnace, they use the coal for converting the ore into steel or iron. Now, because this is a process requirement, it is very difficult to avoid that since steel is required. Then some of the cases, what they are trying is, they are trying, instead of coal, they are trying to switching to hydrogen as a reducing agent in iron making process and use the renewable energy for electric arc furnace. So earlier it was mostly in the blast furnaces. In blast furnace, they use coal and they use the air, and in a special condition, they will burn it and it finally produces the converting to iron. And now people are trying electric arc furnace for especially refining and all, and use the energy from renewable energy. So they have wind power or solar power that uses, and finally they are emitting. Now, when people are purchasing the steel, so somebody who is declaring, okay, what is the emission in construction of a building, they also want to reduce the product's emission, which is used in the construction. So people are looking for who is producing the steel or other material which is having low carbon intensity. So it is also it become a business requirement also to reduce the energy, the emission intensity. Then one Swedish steel company, they are developing a hybrid technology to produce fossil-free steel using green this, but this is not commercialized, and that means it is not large scale. Then in cement industry, again, you can see that in cement industry, in the clinkerization, it produces CO2, carbon dioxide. We cannot avoid that. So it accounts the 8% of global emissions. A significant portion of these emissions are from the chemical process. And also they use In clinkerization also, they use the coal. Then the solution, what it is done is, these emissions are captured, and some of the cases they are using a carbon capturing and storage. And second is, many of the plant they are using alternative fuels. For example, the waste, and it is also mandatory to use a small portion of the waste, like municipal waste, plastic waste, and all into kiln. So by doing that, they are actually reducing the fuel consumption from fossil fuels. Then, by virtue of that, they are reducing their emissions, the emission intensity. And finally, people are trying to use the renewable energy in electric consumption. In a typical case, people may have a captive power plant, like the low-grade coal is used, and that fly ash is used in the cement production. So one example is Heidelberg Material is working on a full-scale CCUS project, and it's plant in Norway, which is targeted capturing 4 lakh tons of CO2 annually, quite huge plant, but it also having its own cost impact. Then, as an engineering fraternity or as a engineering teachers, we also have equal responsibility to share the knowledge. It may be accounting of that, how much we are consuming, and doing maybe the developing of the technologies. This is also a part of the engineering society. So there are a lot of things as an engineering the fraternity we can also do. So especially energy usage, energy efficiency activities, resource consumption, waste reduction, recycling. This all we as an individual or as a maybe the leaders or as professors, you can also do many of the activities. Then engineers are designing a lot of low carbon technologies, starting from a renewable energy system and maybe the storage system, battery storage system, so that we can store the energy that is produced during daytime, and we can reduce the usage of fossil fuels during the nighttime. Then developing sustainable buildings, energy efficient building, sustainable transport, green manufacturing. So this all comes from engineering innovations. So that means there is a lot of aspects. One is in the background. The background is nothing but this is the reduction is mandatory. We don't have any other option, and we are in the emergency situation. We don't have time, so we have to take some of the actions quickly, and this action should have a large scale impact. If impact is less, the reduction will not come. We will think, okay, we are a developing country. We want to use. We will use, but going forward, it is something like a emergency situation. Somebody who is having a cardiac arrest, you have to give maybe a CPR. That is the situation now when you do a comparison. So with that, I hope we understood there's a requirement, and I hope as an engineering fraternity, you also take your and this to your students and maybe other people, and to do a part of this reduction, some role in the emission reduction. With that, maybe I'm open for questions. We have maybe a few minutes time.
Participants, if anybody having any question, please post in the chat box.
If we don't have any questions, as I said, this is a national program for everyone in their own language. A big thank you.
Anybody is having any question, please post in the chat box.
Somebody is asking how we can reach this net zero concept to common person. So basically, we need not go to the very detailed of that one. Basically, scope 1 and 2 emissions is the emissions due to what we use directly or what we directly produce. For example, even in house, there is somebody was also asking a question, any mechanism to check the carbon emission from house, and few of you are asked how we can disseminate to the common person. So one is to emission is nothing but you have the in house scenario, you have electricity consumption. If it is from the grid, there is a multiplication factor that is coming from the CEA regulation, CEA notification, and the electricity authority notification. Even you do a Google searching, you will get that. You can multiply kWh into that emission factor, you get what is the emission due to CO2. Then if you are using a uh, uh, like LPG, liquefied petroleum gas, then for petroleum gas, what is the multiplication factor? So how many kgs of LPG is used in a year or in a month? You have that data. From that, there's a multiplication factor you can calculate. So that is how you can account for scope 1, scope 2 emissions. And other than that, typically houses may not be using direct burning of fuels. Then in case you are using an air conditioner, you can also see in case you done a refilling, you have to get that bill. Okay, how many kgs of or grams of refrigerant you refilled. That data you take it, you can multiply and you get that data. In addition to that, when you do even Google search, there are some of the, and again, diesel consumption for vehicle. So how many liters of diesel consume, there is a multiplication factor. By doing this, you can calculate how much is the emissions. And so some points in research, definitely people are looking for low carbon technologies. That means like green hydrogen, maybe the energy storage. By having energy storage, you can reduce the dependency on fossil fuels, especially during the night time. And you have the green energy may be produced during that time. Then like building construction materials, how you reduce the emissions or low embodied energy. See, for example, you have erected blocks, or mud blocks, stabilized mud block, which is all having less embodied energy. So which this type of technologies or developing low emission technologies, it's a research area. Yeah, that is true. So electric vehicle, if we consume that from solar energy, we can say it produces zero emission during the operation, not during the construction. Scope 3 emissions are there. But during the operation, if you are using solar energy, we can say it is a zero emission only during the operation. Please note, it is not a life cycle emission, zero emission. It is only during the operation. In urban environment, CCUS technology is not seen, since you have to remember that in CCUS, typically we have to drill deep holes, and this CO2 has to pump into deep inside the earth. So typically it is doing out of urban environment where you have, say for example, cement plant, typically near to the mines, etc. And that location is done, and not seen anything on the CCUS technologies in urban environment. And that is also, you have to remember, it is not for a small application where you have large scale emission. Large scale emission, CO2 emission comes from industries. And typically industries are not in urban centers.
Excellent presentation, sir.
Yeah.
I think a lot of learning. You spoke of all that scope 1, scope 2, scope 3 emissions, how to calculate them, and what is the impact of that 1.5 degrees, 2 degrees, and 3 degrees. I was also knowing that 3 degrees is so severe that I think people may perish. Good, good. Any other participants wants to ask any query, please. Because see, when we unmute them, then people, you saw that it becomes a nuisance rather, because we have seen it on, and some people asked for the attendance link. I have placed it again. Please fill it. And some people are told that they could not fill yesterday's attendance. So as a one-time measure, we will give some half an hour time for people to fill yesterday's attendance also. Sir, thank you very much. I think it was a nice hearing to you, and we look forward for your next session. I hope participants are getting benefit, but their reactions are too good, sir. I have seen 70-80% people are told excellent. Their feedbacks, what I have seen yesterday, and I think now also, today also I received your feedbacks on that Google form.
Okay.
Excellent, sir. Excellent. I think we have started. I hope you'll visit us in person sometime, and
Definitely. It will be always a pleasure to meet
yes,
fraternity, engineer fraternity.
yes, sir. Great,
And
great.
if anybody in maybe a last moment, I am also chairman for Society of Energy Engineers and Managers. We also do a lot of awareness program. Every second Saturday, 7:30 p.m., we conduct a technical session. It is free, open to all, and you are most welcome to join. Last 55, 58 months, we are conducting this program.
Great. No, that is very informative session. I attended many of those sessions by, actually they are all stalwarts and industry experts basically. So people who have some idea about industry, they should attend those because the pure theoretical teachers, they may not even appreciate what is being told because they don't understand the nitty-gritties how industries function. But you should have some idea, flair for industry. I think you should attend and benefit from such industry experts basically. I think Joel sir has joined. Madam? I think our next speaker is already there. Joel sir is there.
Good evening, sir. Am I audible?
Yeah, clearly audible, sir. Sir, thank you, Benet George, sir, for your
Thank you very much.
informative talk.
Thank you, everybody.
It's time up now. I think you have properly utilized the time today. I think we look forward for your next session soon.
Sure.
Thank you, sir. Thank you.
Thank you so much. Yeah. Good night.
Good night, sir. Yes, Dr. Shivani, I think the next speaker may be introduced.
Good evening, all. Now I am hand over mic to the Mrs. Veera Rawal, ma'am, to introduce our next speaker. Thank you.
all the participants kindly note that the link for attendance today has been given now for the session 1, and the session 2 will be posted in the chat group in some time from now when the session starts. So, and for yesterday also, some people have requested me to keep the link open. So I'll keep the link open for till 9 o'clock today only as a one-time exception. But henceforth, please don't do that. In the session itself, the attendance link is floated. So kindly fill the attendance link citing your roll number in the chat box only. Thank you.
Thank you, sir. Am I audible, sir?
Yeah, you are clearly audible.
Good evening to everyone present here. It is my great honor to extend a warm welcome to our today's guest, Mr. Joel Asaria, sir. He is the Director of Energy Management at the National Productivity Council, Ministry of Commerce and Industry, Government of India. He holds a BTech degree in chemical engineering, ME in energy engineering, where he was a gold medalist from Anna University, MSc in ecology and environment, MBA from ICFAI, and at present he is also pursuing his PhD from NIT Trichy. With over 25 years of experience, he is an expert in energy management, energy audits, environmental system, pollution control, waste minimization, and renewable energy. He began his career in the private sector, including work at Bokura Group and the leather industry before joining the NPC. He has also served in Ministry of New and Renewable Energy. A certified energy auditor and lead auditor, he holds several international certifications in quality and project management. He has led over 100 audits and consultancy projects, co-authored manuals on energy efficiency, and contributed to various national and international programs. He has represented India in countries like Bangladesh, Bhutan, Singapore, Vietnam, and Sri Lanka for consultancy and training initiative. May I now request to Mr. Joel Asaria, sir, to enlighten us with his knowledge and insight as he begins the today's session. Thank you, sir.
Thank you, madam, for nice introduction. Let me share my screen and we will continue the session. Am I given sharing option? Sharing, right?
Yes, sir. If you're host, you have that sharing option, sir. Let me wait a minute. One minute. Let me click. You are co-host, sir. You can share. Yeah. Your screen is visible, sir.
Is it clear? Is it visible,
Clear,
sir?
sir. Audio is clear and your screen is totally visible.
Dear friends, good evening to you all. So in this session, we will discuss on national and global policies on sustainability. Sustainability policies are very crucial, which guide governments, business, and communities towards a balanced path of economic growth, environmental protection, and social well-being. Both national and global policies, they align towards sustainable future. This is my outline of my session. First, we'll discuss on various global as well as local sustainable issues, challenges, what we are facing today. Then we'll understand concept of sustainable development. Then we will see evolution of sustainability policies. Then we'll discuss sustainability policies, global perspectives, and we also see India's sustainability policies, then future trends in sustainability, and also challenges in implementing sustainability policies. Then finally, we will discuss on role of academia and professionals in policy implementation. So here we start with energy use since the beginning. In the beginning, the earliest energy source was wood. So we were using wood for all our energy requirements, which led to extensive global deforestation. So firewood basically we were using. So you can see from 1850s, at that time, more than 80% coming from wood only for our energy requirement. Then followed by wood, the second major source was coal. Coal we started using after industrial age. So in the beginning, in 1850s, the coal was less than 20%. Again, the usage increased to maximum 80% in 1920s. So there was an industrial age began during that time. So the coal consumption was more at that time. Then we started using oil and gas from 20th century onwards as a primary energy source. So the oil consumption also went to peak in 1970s. So in addition to these fossil fuels, we also started using nuclear power from 1860 onwards. If you look at global energy consumption breakup, world mostly relies on fossil fuel. So more than 70% coming from fossil fuels. Fossil fuels are your conventional fuels, coal, oil, and gas. Only 28% are coming from renewable energy sources. So out of 28 also, maximum is coming from wind energy, followed by solar, then biopower, and other geo concentrated solar power and ocean technologies. So 50% contributed from small hydro. So from this we can understand that as of now there has been no sustainable development across the world. So because of more than 70% we still depend on fossil fuels. Because of massive production and consumption of fossil fuels, there are global and local sustainable issues we are facing today. Some of the global issues are global warming and climate change, acid rain, ozone layer depletion, loss of biodiversity, and air pollution. So this is also transboundary. So when you emit any air emissions in your country, so it will be carried away to the boundary of the next country. So it is a transboundary issue, air pollution. Then some of the national or local issues are deforestation, water pollution, then water scarcity. We have other issues like desertification and soil erosion. These are all the national sustainability issues we are facing because of use of fossil fuels. Global warming and climate change, as you all know, this is due to greenhouse gas emissions, the main gas is CO2. So because of this increased warming of Earth, our global average temperature, it's about 15 degrees centigrade, it has risen to 0.8 degrees centigrade over a period of 100 years. So scientists and evidence confirm that this global warming is due to industrial activity only, mainly consumption of fossil fuels. According to Mr. Mark Linasa, so he is a scientist, he has written a book on 6 degree. So you can see in Google also this 6 degree. So he explained the impact of this climate change, every degree change, what is the impact. When the temperature, global average temperature rises by 1 degree, this is the impact, what you are seeing here. Ice-free sea. The sea absorbs heat, fresh water will be lost, and low-lying coastal lines will be flooded. Most of your cities are located near the coastal region. So if you allow 1 degree rise from 15 to 16, so the all low-lying coastal cities will be flooded. Then rise up to 2 degree, 15 plus 2. Heat stroke, forest fire, stressed plants beginning to emit carbon rather than absorbing. So this is the impact of 2 degree rise from the average level. Then 3 degree rise, carbon release from vegetation and soil speeds global warming, death of Amazon rainforest. So this is the major impact if you allow 3 degree rise. And super hurricanes hit coastal cities, starvation start in Africa. When you allow 4 degree rise, then permafrost makes global warming unstoppable. Permafrost means this is a frozen soil above the soil. It will have dead biomass. When this permafrost, that is a frozen soil, melts, then your dead biomass will be exposed to the hot radiations. Then again there will be a decomposition and there will be CO2 emissions. So this will make global warming unstoppable, and much of Britain will be made inhabitable by severe flooding. This is the impact of 4 degree rise. 5 degree rise, methane from ocean floor accelerates global warming. Ice glaciers will melt in both poles. Human migrate in search of food. This is the 5th impact. Then if 6 degree, if you allow it to 6 degree, that will be end of life on Earth. So this is how he explained the impact of each degree rise from the global average temperature. So that's why all global nations, countries, they are coming forward, and they are trying to address these issues with the help of many convention treaties and net zero. So all these schemes, green funding, everything is because of this global warming to reduce the impact of greenhouse gases. Sea level rise. So this is the photograph based on the satellite data taken with the help of 3 satellites. It confirms the rise in sea level from the existing level to up to 50 mm rise. So far we have seen the impact of global sustainable issues and challenges. So to address these issues, we must have sustainable solutions for sustainable development. This is the statement of sustainable development. Sustainable development is the development that meets the needs of the present without compromising the ability of future generations to meet their own needs. It means all our consumption of fuels, energy, resources should be in an optimized manner so that we leave some energy for our future generation. So that is the need of the hour to discuss on sustainability policies which lead to sustainable development. First, we'll discuss on the policies at global level. Why global policies are important? The first reason is environmental protection. So these policies will support environmental protection and climate change, and this will help to keep the temperature rise within 2 degrees centigrade in the next 100 years. Then climate change mitigation, this is also addressed by many policies for reducing greenhouse gases, and this will support climate change mitigation. Then resource conservation, as I said, our fossil fuels are exhausting day by day, so we will not be having enough fuel after 150 years. So policies will lead to optimized use of resource through energy efficiency solutions. Then social well-being, social equity is nothing but ensuring basic needs equally to all people is the social equity. So these policies ensure social equity. Economic viability, nothing but encouraging long-term businesses which consume less fuel and which adopt sustainable development solutions. So this policy will lead to economic viability. Then biodiversity preservation. So because of this climate change, global warming, we are losing special microorganisms. So they are very, very important to keep the ecological cycle. We are losing these microorganisms every year. About 50,000 species we are losing every year because they are all very sensitive to the temperature change. So policies related to biodiversity preservation will lead to preservation and protection of the biodiversity. Then global cooperation frameworks. So these policies will support and also will make global countries. They will lead to international cooperation and combined efforts to address these issues. Now we will see evolution of sustainability policies. The evolution began in 1972 during a Stockholm Conference on the Human Environment. It was the first global call for sustainability. Then followed by this Stockholm Conference, then 1987 Brundtland Report. So this report introduced the concept of sustainable development. So the definition we have seen, the definition was introduced in Brundtland Report of 1987. Then in 1992, Earth Summit held at Rio de Janeiro. There they adopted Agenda 21, and that time there was commitments towards climate change and global warming. So UNFCCC, United Nations Framework Convention on Climate Change and Convention on Biodiversity. So these are all the components of this Earth Summit. Following this, in 2015, Paris Agreement was launched. So it is for global climate action framework to limit global warming to well below 2 degree rise. So we discussed the impact of temperature rise. So the Paris Agreement is very, very significant because it support all policies to limit global warming to well below 2 degrees centigrade. The UNFCCC, it was adopted in 1992 during the Earth Summit, and there were 197 parties to this UNFCCC. So these parties, they meet annually to negotiate and review the different activities related to climate change and global warming. Milestone COP meetings. Third COP meeting that was held in Kyoto in Japan, called that in the year 1997. So which has led to CDM and other related market-based mechanisms. Then the other important COP was COP21 that happened in Paris in the year 2015. Then COP26 in Glasgow in the year 2021. So there were discussions on net zero pledges. COP28 happened in Dubai 2023. The focus was on renewable transition. Then the last one, COP29, held in Baku 2024. There the focus was on climate finance commitments. So both this UNFCCC and COP process remains central in shaping global climate governance and fostering collaboration among nations and driving commitments towards sustainable and low carbon future. Kyoto Protocol 1997. So in COP3, so this was launched. It was the first legally binding treaty which set emission targets for developed countries. The protocol introduced three market-based mechanisms. The first one is emission trading, allowing countries to trade surplus emission allowances. Suppose there are two countries, so there will be a target for each country to reduce their greenhouse gas emission. So if a country achieves the target in excess, so that excess target can be sold to other countries who are short of achieving these targets. This is the emission trading. Clean Develop Mechanism, CDM, is nothing but this mechanism help developed countries to invest in emission reduction projects in developing countries. They are called Annex 1 countries under this mechanism. We are non-annex countries, developing countries like India, China. So developed country like US, they can invest the CDM projects in India. So that is the understanding of CDM. So they will financially support CDM projects in developing nations to achieve their targets. Joint implementation, JI, this allows developed countries to earn credits by investing in emission cutting projects in other developed countries. So this joint implementation happens between two developed countries, so they can exchange their credits. This Kyoto Protocol, the first implementing period started in the year 2008 to 12. So again, the second phase started in 2013 till 2020. But this Kyoto Protocol was not successful because many of developed nations, they have not signed this document. So that's why it's not successful one. Paris Agreement is the most significant treaty on climate change. So according to this agreement, each country has to submit nationally determined contribution called NDC. For India also we have NDC, and also as we discussed earlier, it commits nations to limit global warming to well below 2 degree, preferably 1.5 degree centigrade. So that is the main requirement for this agreement. India's NDCs include reducing emissions intensity by 45% by 2030. So this is our NDC. So the next one is United Nations Sustainable Development Goals. I think this topic already discussed by my previous speakers, maybe yesterday's speakers also. We will understand only the important points of this UN SDG. There are 17 goals and 169 targets adopted in 2015 by United Nations member countries. It covers poverty eradication, gender equality, clean energy, sustainable cities, responsible consumption, climate change, peace and justice. India, we have integrated all these SDGs into our national development agenda, like Niti Aayog, SDG index. So we have incorporated these SDGs in our programs. Next, the global policies. European Union Green Deal. It was launched in 2019 by the European Union. It is a comprehensive strategy to make Europe the first climate neutral continent by 2050. Key objectives include transition to clean energy, boosting renewable energy and energy efficiency, promoting circular economy with sustainable production and consumption, protecting biodiversity, restoring ecosystems and reducing pollution, fit for 55 package. It's nothing but immediate implementation target of 55% cut by 2030. European Union emission trading system and carbon border adjustment mechanism, large scale investment in green technologies. So these are the important objectives under this European Union Green Deal. Next is about sustainability policy of US. They also have a range of policies aimed at addressing climate change, energy transition, and environmental protection. So they are all supported by federal laws, executive actions, and state level initiatives like Clean Air Act and Clean Water Act. So to regulate environmental pollution, energy policy acts. So this will take care of energy efficiency and renewable energy and clean energy systems. Paris Agreement. So US also joined this Paris Agreement in 2021, and they started addressing climate actions. Next one is Inflation Reduction Act 2022. So in this, major investments in clean energy, electrical vehicles, green manufacturing, and carbon reduction. So these are all the coverage under Inflation Reduction Act. So this act supports major investments in clean energy. Next is executive orders on sustainability. So under this, all federal government operations towards clean energy, zero emission, and sustainable solutions. State and local initiatives include clean energy, zero emission vehicles, and climate resilience operations. So these are the various schemes and activities which are supported by US sustainability policies. Next, China's sustainability policies. They are the world largest emitter of greenhouse gases, followed by US, and we are the third largest emitter of your contributor of your greenhouse gas emission. So they also have sustainability policies to balance rapid economic growth with environmental protection, like carbon neutrality policy, commitment to peak carbon emission before 2030 and achieve carbon neutrality by 2060. So the carbon neutrality policy they have to achieve carbon neutrality by 2060. Then other policies for renewables, especially to promote solar and wind energy, hydro energy systems in China, massive investment in renewable energy systems to become world leader. They have national carbon market for emission trading system, and also there are policies for battery and electrical vehicle manufacturing. So their objective is to become world leader in battery and electric vehicle manufacturing. They also have policies related to circular economy. Circular economy deals with waste recycling and resource optimization, and they have pollution control policies. Then Belt and Road Initiative, Green BRI. It's nothing but wherever they do projects overseas, they will follow sustainable standards in those projects. So these are the sustainability policy of China. G20 and some of the global initiatives. G20 represents world largest economies. They play a pivotal role in driving global sustainability by aligning economic growth with climate action and green transitions. Then we have other initiatives like UN Decade on Ecosystems Restoration 2021-2030, global efforts to restore degraded ecosystems. The next one is One Planet Summit, Mission Innovation and Green Climate Fund. This also supports collaboration, technology sharing, and funding for sustainability. In India, we have initiative during G20, the popular life initiatives. So these are the global initiatives towards sustainable development. The Organization for Economic Cooperation and Development, they also play an important role in shaping the sustainable policies across the globe. OECD guidelines for multinational enterprises to encourage responsible business practices in areas like human rights, labor, environment, and anti-corruption, green growth, climate, and energy policy recommendations. Then the next one is environmental social governance reporting. So this also has emerged as a global standard for assessing corporate sustainability and non-financial performance. Now, many countries and stock exchanges are making ESG disclosures as mandatory to promote transparency and responsible investing. Biodiversity policies to conserve ecosystems, as I said, special species, microorganisms, and genetic resources. We have global biodiversity policies like Convention on Biodiversity 1992, and we also have Aichi biodiversity targets 2011 to 2020. It set 20 global biodiversity goals. Then Kunming, it is a Montreal Global Biodiversity Framework, in short called GBF framework, GBF 2022. It was adopted at COP15, committing nations to protect 30% of land and oceans by 2030. It's also called 30 by 30 target, to protect 30% land and 30% oceans by 2030. Next one is CITES, Convention on International Trade in Endangered Species. It regulates trade in endangered species. So these are all related to biodiversity policies. We have global level policies on ocean and marine. Mainly these policies focus on conserving marine ecosystems, regulating ocean use, and ensuring sustainable development of coastal and marine resources. They address critical issues like overfishing, pollution, ocean pollution, biodiversity loss, and impact of climate change on oceans. We have seen sea level rise and also the uh, melting of glaciers. So the cold water coming from glaciers will dilute your ocean water, and there will be a change in temperature. Because of this temperature change also, there will be loss of biodiversity. So to address these global issues related to ocean marine, there are policies. This UNCLOS is for sea. So this policy talks about protection of biodiversity and ecosystems in ocean. Then High Seas Treaty, this is also important treaty. This also for addressing issues related to ocean. Then International Maritime Organization conventions, IOMA conventions we have. Then under Sustainable Development Goal 14 also, there's a provision to take care of marine ecosystems and plastic pollution in ocean. So these are the important policies, global policies for ocean and marine protection. Next important thing is global green finance. So this is nothing but supporting global sustainable projects through financing like green bonds and sustainability loans for renewable energy, clean transport, and sustainable infrastructure. Then there are climate funds like Green Climate Fund, GCF. So under this fund, they support all projects related to this greenhouse reduction, related to climate action. sustainable investment funding, integrating ESG criteria into portfolio management, then carbon markets, trading of emission allowances. So we discussed in Kyoto Protocol, CDM, Clean Development Mechanism. So in that, you can trade your emission reduction with the other countries who are ready to purchase. So in the previous session, there were discussion on net zero emission and how to calculate these emissions, how to calculate CO2 equivalent of emission from each fuel. So if you save 1 ton of CO2, if you reduce 1 ton of CO2, it is equal to 1 certificate emission reduction, 1 CR. So that is the certificate. So you can trade that certificate in other countries. It is a carbon market. So for each certificate, there will be a market value. So in India also they started. So approximately for one certificate, some 1,000 rupees. So like that you can sell your certificate which you obtain through this energy efficiency projects or any carbon reduction projects. There are about $600 billion per year investment for climate finance. How these global sustainability policies influence our country, India? So these policies accelerated our renewable energy transition. So we have targets 500 gigawatt by 2020, and there are policy reforms in energy efficiency, sustainable mobility, and waste management. So the energy related policy reforms and sustainability related policy reforms are all coming from your global sustainability policies. So we take inputs from these global sustainability policies to reform our policies. So because of these policies, global policy, uh, there is an accessibility to uh, climate finance. So we can make use of the funding, global funding available under this green financing, and we can adopt best practices, benchmark across the globe through technology transfer, and there will be trade impacts due to these global policies. So the policy uh, launched at global level definitely will impact at national level. To strengthen India's role for sustainability, so these global policies are helpful. So some of our initiatives like International Solar Alliance we have, and we launched Lifestyle for Environment. So for these initiatives we got from global sustainability policies. So far we have discussed on global sustainability policies. Now we will discuss on Indian policies on sustainability. For India also, these policies are very, very important. So these are all the reasons for balancing economic growth and environmental protection, for our climate change adaptation and mitigation issues. Here also, to manage resource scarcity, we should have a good policy for improving public health, promoting green infrastructure and urban development, for fostering innovation and green technology, for long-term economic benefits. So here we support and also encourage projects, sustainable projects, building a circular economy, enhancing global leadership, addressing social equity. So for all this, we should also have national policies on sustainability. So I will discuss one by one in subsequent slides. So in India, according to our constitution, Indian constitution, we have articles 48A and 51AG. This gives provisions for environmental protection, reflecting the nation's commitment to sustainability and ecological balance. The Article 48A mandates the state shall endeavor to protect and improve the environment and to safeguard the forest and wildlife of the countries. And also the Article 51A(g) mandates that it shall be the duty of every citizen of India to protect and improve the natural environment, including forests, lakes, rivers, and wildlife, and to have compassion for living creatures. So, in our constitution itself, we have provisions to take care of our environment and also for sustainable development and ecological balance. So our constitution itself have articles related to sustainable development. So other frameworks, policy frameworks are National Action Plan on Climate Change, NAPCC. It was launched in 2008. Then we have other state level action plans on climate change, SAPCCS. The first one is National Action Plan on Climate Change. It was launched in the year 2008. It is the cornerstone of India's climate strategy. It is based on the principle of co-benefits. That is, climate action can simultaneously promote sustainable development as a co-benefit. It has 8 national missions. The National Action Plan on Climate Change has 8 national missions. National Solar Mission, so which takes care of solar penetration in India, solar rooftops, concentrated solar power, and solar manufacturing. Then the next one is National Mission on Enhanced Energy Efficiency. So this mission covers energy efficiency and many schemes to promote energy efficiency in industries, in buildings, like you have PAT scheme, demand side management schemes. Then we have a National Mission on Sustainable Habitat, National Water Mission, National Mission for Sustaining the Himalayan Ecosystem to protect the Himalayan ecosystem. Then we have National Mission on Green India, National Mission on Sustainable Agriculture, National Mission on Strategic Knowledge for Climate Change. So these are the important 8 missions under National Action Plan on Climate Change. The first one is National Solar Mission. It is called Jawaharlal Nehru National Solar Mission, JNNSM. It was launched in 2010. The main aim was to make solar power cost competitive energy source within our country. So you can see the achievement of this solar mission. Initially, we had less solar installations. In 2022, The solar installations, the solar capacity was 20 gigawatt, that is 20,000 megawatt. Now it is more than 100 gigawatt of solar installed capacity. So these policies related to this mission, so they are supporting and encouraging the investments in solar power. What are the achievements out of this mission? Rapid expansion in grid connected solar projects, and also encouragement for domestic solar manufacturing. So we have now our indigenous manufacturing units for manufacturing solar panels. Next one is Energy Conservation Act and efficiency policies. The Energy Conservation Act was established in 2001. So from this act, Bureau of Energy Efficiency, it was formed in 2004. So since 2004, Bureau of Energy Efficiency is doing a lot of activities to enhance energy efficiency in all sectors, buildings, and they have many schemes like FAT scheme for industries. All energy intensive industries are given targets. So, for example, specific energy consumption. If there is an industry manufacturing automobiles, to produce 1 unit of automobile, how much is the energy consumption? And if it is some units of energy, for example, 100 units of electricity per 1 unit of production, so they will be given target to reduce by 5% from this 100 unit SEC, specific energy consumption. So every year they have to reduce their target and submit energy returns to Bureau of Energy Efficiency. Like in the case of financial audits, we submit IT returns. So they have to submit energy returns for Bureau of Energy Efficiency based on their targets. There will be baseline energy audits to these energy intensive industries. As of now, there are about 12 energy intensive industries like aluminum, cement, refineries, then railways, chlor-alkali industry, thermal power plants. So all major industries will be given this target according to perform achieve trade scheme of Bureau of Energy Efficiency. So this FAT scheme help the industries to go for energy efficiency technologies and reduce the energy consumption. So this will lead to energy reduction, as well as there will be environmental benefits also. So this is an important initiative for sustainable development. Then other energy efficiency financing platform, EEFE, facilitates investment in energy efficiency. It supports MSMEs and in industries towards energy efficiency projects. So there are soft loans given by the banks for implementing these energy efficiency options. Standards and labeling scheme introduced by Bureau of Energy Efficiency. They will set minimum standards, minimum efficiency levels for all home appliances. They started with fluorescent tube lights and refrigerators and air conditioners. Now more than 20-25 appliances are given this star rating as standards labeling by Bureau of Energy Efficiency. And to improve energy efficiency of buildings, Bureau of Energy Efficiency they introduced Energy Conservation Building Code called ECBC. It sets minimum benchmarks, minimum energy efficiency standards for commercial building performance. So there are star rating scheme for buildings also introduced by Bureau of Energy Efficiency. They are all for office building and BPOs and IT buildings, hospitals, shopping malls. So they can apply for this star rating or Bureau of Energy Efficiency. Other schemes for promoting energy efficiency in India by Bureau of Energy Efficiency. In 2009, Budget Lamp Yojana was introduced to replace the old inefficient incandescent lamp with CFLs, composite fluorescent tube lights. Then Ujala scheme, it was introduced in 2015. So more than 4 crores of lights were replaced with LED lights. It was a huge savings from the demand side. Standards and Labeling Scheme, it was introduced in 2005. We have just discussed. Energy Conservation Building Code, it was introduced in 2007. PAT was introduced in 2010. Energy efficiency in small and medium enterprises. There are schemes, subsidies. If they invest in energy efficiency technology, then 30% they have to invest, 70% support from the state and central government. Demand side management. So there are scheme related to demand side management also. Renewable energy policies in India. So to meet growing energy demand and rising import and also dependency on fossil fuels, and also to meet international commitments to reduce greenhouse gas emissions. So we are moving into renewable energies. So for renewable, to increase the propagation of renewable energy in India, there are many policies supporting solar, wind installations in India. So we started in 1980s with small supports. Now we have programs, many schemes supporting renewable energy installations. We have a dedicated ministry, Ministry of New and Renewable Energy. Under MNRE, we have other institutions, National Institute of Solar Energy, National Institute of Wind Energy, then IRADA for financial assistance. Then we have National Institute of Bioenergy. So these are the institutions which propagate renewable energy installation through policies and schemes. These are the policy frameworks related to renewable energy. First one is Electricity Act 2003. This is the basic foundation for other policies and regulations. National Electricity Policy 2005 and Tariff Policy for fixing of tariff, solar power, wind power. It was amended in 2006 and 2016. National Action Plan on Climate Change. This we discuss. There are other renewable energy development programs, renewable energy targets and missions, policies related to hybrid and storage, green hydrogen policy 2022, decentralized renewable energy policies, and policies for circular economy and waste energy. So these are all the policies related to renewable energy. Electricity Act, it mandated promotion of renewable energy in power generation and enabled SERCs, State Electricity Regulatory Commissions, to set renewable purchase obligation, RPO. So each and every consumer, according to this RPO, there are obligation of using certain percentage of renewable power in their total power consumption. If I consume 100 kilowatt power, so at least 10%. So 10 kilowatt should be from renewable energy. So this is the requirement under this RPO. And also this act introduced concept of open access, allowing renewable energy generators to sell directly to any consumer with the help of these open access systems. National electricity policy and tariff policy, they mandated preferential tariffs. Tariff means fixing of selling price of electricity generated from renewable energy. They also introduced renewable energy certificates. As I said, carbon emission reduction certificate, there are REC, renewable energy certificates also. So that can be traded in market. So this is also done for promoting green power. Other renewables development programs are for solar. We discussed JNNSM. It boosted solar parks. So many megawatt size solar parks across the country. Rooftop solar system, there are policies and schemes, state level as well as central level schemes. Subsidies are available if you go for rooftop solars up to 10 kilowatt system. Solar manufacturing, like indigenous manufacturing of solar components. Wind energy policy, it was introduced in 2015, which transitioned feed-in tariff to competitive bidding scheme to reduce the cost. So all the wind energy suppliers, they got benefited because of this competitive bidding process. National Bioenergy Mission to promote biomass, bagasse cogeneration and waste energy projects through
I think your voice is
different
breaking, sir.
financial. So we are going to, let me check. Maybe due to internet issues. Is it clear, sir, now?
Now clear, sir.
Okay, sir. So we have a national offshore wind energy policy for wind energy projects into the ocean. So in India, we have more than 7,600 kilometer coastal region, starting from West Bengal till your western side, 7,600 kilometer coastal zone. So we are planning to develop offshore wind turbines of about 500 megawatt in Gujarat as well as in Tamil Nadu. So these are our future plans. We have completed the feasibility study for having wind turbines in ocean. So that this whole project is run by offshore wind energy policy. We have wind, solar, hybrid and storage policy. So this came in 2018. Here we are combining two renewable energy sources, wind and solar. They are complementary to each other In the daytime, we get solar energy. In the night time, we'll get wind energy. So we can store the energy in the night time. With the help of battery, we can get continuous power. So the only issue with renewables is they are intermittent in nature. So we cannot get reliable power, stable power. So that's why with the help of proper storage system, we can have reliable and continuous power. So this policy led to low overall cost of the hybrid projects. The next scheme which is supporting sustainable development is Kusum. It was to help the farmers. The farmers need electricity to run their pumps. Now, according to this scheme, so they will be given subsidies for buying solar pumps. So there will be a solar panel with DC, because solar generates direct current. So they can have 0.5 to 2 HP solar pumps. So using these solar pumps, they can have up to 1,50,000 liters per day of water for their agricultural field. So this scheme supports irrigation and significantly reducing electricity bills and reliance on diesel. So it reduces the carbon footprint of agricultural activities. This is a very good scheme, supports farmers. Green Energy Corridor Project. Again, the existing grid facility, grid infrastructure is not suitable for injecting of electricity generated through renewable energy sources. So their quality issues, it may affect the quality of your power. So to improve the grid infrastructure, we came out with the Green Energy Corridor Project. It facilitates the transmission of renewable energy from resource-rich areas, because the renewable sources are location specific. So only few states are having a wind potential. So they need to transmit that power from these specific locations to other places. For that, we need grid infrastructure. So we need to improve the national grid infrastructure. The benefits are grid reliability, smoother integration of renewable sources into the grid. So green energy corridor projects, they are linking all southern grid and northern grid, east and western grids into one, so that the evacuation of renewable energy power will be very, very easy. Circular economy and waste energy. So through these concepts, they are also complement to each other, because it's a take, make, dispose model. So initially, the traditional model was take, make, and dispose. Now it has become closed loop system in circular economy. So this lead to minimum waste and maximum resource. So both circular economy and waste energy support sustainable production and consumption. Core principle in circular economy: reduce, reuse, recycle, and recover. So in circular economy, your products, materials, and resources are in use for as long as possible. So they try to reuse the waste, minimize the waste, recycle the waste, and recover the waste. They want to keep these materials as long as possible in the closed loop. Benefits: reduce environmental impact, then your fuel consumption will be less. It creates jobs also. Waste to energy: so under this, all non-recyclable waste are converted into useful forms of energy, like your garbage waste and landfill waste. From landfill we get methane and other waste with the help of incinerators, because all these waste have some heat content, calorific value in that. So we can feed into any incinerator. The heat generated can be used for generating steam, and we can generate electricity. We can generate heat with the help of waste to energy technologies like incineration, anaerobic digestion. In anaerobic digestion, your agricultural waste and food waste can be converted into biogas. We have gasification process to convert bio waste into producer gas. We have pyrolysis technology. So all this help to convert waste into energy. Because of our renewable energy policies, we could achieve 180 gigawatt renewable capacity. We are one of the top countries globally. Solar tariffs have fallen to record as low as 2 to 2.5 per unit. So because of competitive bidding approach, your price, unit price have come down to 2 to 2 point rupees per unit. Earlier it was more than 10. Renewables now account for, so we have 40% renewable installations because of success of renewable policies, and also other benefits: job creation, reduced and oil and coal imports. These are the benefits from renewable energy policies. So other policies related to renewable energy, like market oriented mechanisms with competitive bidding, green markets and carbon trading, energy storage, hydrogen and digital grid technologies for reliable renewable energy integration, then regional and international cooperation including solar. We have International Solar Alliance. There are more than 170 countries. So we exchange our ideas related to solar. Just energy transition, ensuring economic and social sustainability along with clean energy growth. So this is our future trend related to renewable energy. Other policies like National Electric Mobility Plan, which is nothing but electric vehicle movement in India. We have National Water Mission, Swachh Bharat Abhiyan for sanitation and waste management. So in this, there are many options and strategies for recycling of waste and management of waste. So we are going to celebrate this Swachh Bharat again this month, starting from I think September 17th till October 2nd. We celebrate Swachh Seva. For under this, there are many task activities to be done for sanitation and waste management. Then we have a separate hydrogen mission for green hydrogen production So under Making India, we now have a policy for green hydrogen. So we'll discuss in subsequent slides. First, we'll discuss on electrical vehicle. The reason for moving towards electrical vehicles are pollution, and also due to pollution there are serious health issues, and also carbon emissions. So because of these carbon emissions, global warming, climate change, we discussed many global environmental issues, and we need to import oil for all our automobiles, because we have only less than 1% of the total world reserve, oil reserve. So now more than 90% of our oil requirements, we depend on imports only. So here electric mobility policies, NEMMP, National Electric Mobility Mission Plan. It was launched, and also faster adoption and manufacturing of hybrid and electric vehicles. So these two were launched to accelerate electric vehicle adoption in India. So because of that, so our oil imports will reduce, emission will reduce, particularly CO2 emissions will come down, and there will be new markets in battery and charging infrastructure. So these policies will lead to markets in battery and charging infrastructure in future. Lifestyle for environment. This was introduced in COP26. It emphasizes sustainable living at the individual and community levels. Example, reducing single-use plastic, saving energy, conserving water. So these are all the different examples under lifestyle for environment. Green hydrogen policy launched in 2022. Our target was 5 million metric ton of green hydrogen. So we have allocated 19,000 crores to incentivize private sectors into green hydrogen manufacturing. So there are a lot of opportunities for electrolyzer manufacturing, green steel manufacturing, fuel cell manufacturing in the future to support this green hydrogen mission. So in the mission documents, that green hydrogen policy, so whatever we are discussing here, all are available, all documents detailed. If you want to go in detail about each and every policy, you can refer the documents. These are all available on the net. Success stories of policies, sustainability policies, we understand through case studies. International Solar Alliance, this promoted solar deployment in over 120 countries. And this European Union Green Deal, this also aims for carbon neutrality by 2050. Costa Rica, which generates nearly 100% of its electricity from renewable sources. China's large-scale investments for renewables. And also in Bhutan, they could achieve carbon negative status, because everywhere you can see vegetation. They maintain the percentage of vegetation in their country through strong forest conservation policies. So far we discussed global sustainability policies and also national India's policies. Now what are the lessons we must take from global leaders? From European Union, circular economy approach, we need to adapt. USA has strong financial incentives for their sustainable development initiatives. China, large scale investment for renewable deployment. In India, we need stronger enforcement and financing support. Future trends in sustainability, net zero commitments. So there are many policies for net zero commitments. Then digital technologies. For digital technologies, again, there will be policies, artificial intelligence, machine learning, IoT, then VR-based digitwins we are using for energy efficiency, data analytics, automation for industries. So there are many technologies. So we need to have better, attractive sustainability policies for these technologies. Green hydrogen. So this is also going to be a future fuel, green hydrogen. Then there may be requirement for battery storage system policies, carbon capture policies, and there may be policies in future for sustainable finance and ESG investments in India. These are the challenges for implementing sustainability policies. Despite we have ambitious policies, there are barriers like financing. Developing countries need climate finance support from developed nations. So all developed nations, they are not ready to support developing countries like India, China. They should support for our sustainable developments. Technology transfer. So this is also important factor. So they are not ready to share their low carbon technologies to developing countries. Public awareness, again, the citizens or everyone should aware of policies regarding the sustainable development. Then only it will be successful. Political will, again, will hinder the developments because all policies require political support also. And other is balancing growth and sustainability. So industrial growth with environmental protection is very difficult to achieve. So it is very difficult to balance industrial growth with environmental protection, particularly developing countries. What is the role of academia and professionals as far as sustainability policies are concerned? Academic institutions and professionals, we have a central role in bridging policy and practice. So our contributions include conducting applied research on renewable technologies, energy efficiency and sustainable practices. We need to include sustainability into our curriculum, our engineering, management and social sciences. We need to partner with industry and government on pilot projects related to sustainable developments. We need to train the people on sustainable practices. We need to create awareness through community outreach. And there are other opportunities like we can make use of international funding. We can do international projects on sustainable development, and we can tie up with international institutions for technical collaborations. So these are all required for academic level as far as sustainability policies are concerned. To conclude, both national and global sustainability policies, they are all supporting for achieving global level sustainable development. It is shared responsibility. So we should have international cooperation and uh, combined approach to address our sustainability issues, local as well as global issues. In India, we have policies right from NAPCC to recent mission life and green hydrogen and offshore policies. So this shows our commitment to sustainable development. And international agreements, they also show that nations are willing to come together for a common cause, but the success depends on implementation and integration of these policies into everyday practices. As educators and professionals, we must equip ourselves and our students with knowledge, skills, and values that support sustainability. So, with this, I conclude my session. Thank you very much. If there are any questions, so this is basically a session to make you understand the basic concepts related to sustainable development. There are no technical things here. If you go into detail about any policy, so you can refer the international websites and our Indian websites for more details. Thank you.
Thank you so
Okay.
much, sir. Any questions from the audience, participants? If you have any question, please post.
Excellent, excellent session, sir. Really, I think you have taken a lot of time and efforts to compile all the data and put it in place. Nowhere it is available. You have
If
taken
it
that.
had been a technical session, I could have given lecture without referring to any PPTs.
Yeah,
But
yeah.
since it's related to policies, I need to prepare some PPTs and compile the data.
Very extensive research you have done onto this. Really appreciate, sir.
Thank you, sir. Thank you.
And I had the opportunity to hear sir in Kolhapur actually at that Goshima summit. So I saw this gentleman is very committed to his work, so I requested him, and really he has done a wonderful job. I think even I attended many PhD open defense. This was far, far, far better than what I heard so far. No, really, and the amount of inputs you have given. A lot of takeaways. People can do definitely. I think you are doing PhD, so you are very passionate about all these things. I think many faculty also are here who are pursuing their research. So this can help actually. And academia, sir, I'd like to add that UGC has mandated all the universities to set up their curriculums based on the SDGs. All the curriculum should be in sync with sustainable development goals. It is a mandate given by UGC, which controls all the universities pan India. And even these engineering institutions, they are supposed to incorporate SDGs in their projects, internships, and all those things, so that the outcomes are attained, and that we don't cross that 1.5 degree. Sir, there is a question: what are the biggest barriers to achieving the SDG targets? One of my learned colleague is very concerned about SDG. So, what are the biggest
So
barriers?
challenges we have discussed. So what are the implementation challenges? So like so policy requirements like political support, financial supports. So these are the main barriers. One is financial support. We don't have finance like other countries. There are subsidy, there are green finance, but tapping that international finance is very difficult sitting in India. So in our
Yes.
country, but the support is very low. Financial support is very, very less. That is the main barrier. All other barriers can be manageable.
Okay.
Any other question?
Another question. I think there are no questions now.
I think time is also up, sir.
Yes.
So,
Are all tired or what? It's 9 o'clock. They can reserve their questions. They can send through email to the organizer. So if they can send me, I can reply your queries.
Yes, sir. Certainly, we'll place your mail ID on the group, or we'll take the questions and we'll mail you. It was very informative session. We really got to know SDG very simplified. Everyone is talking about the SDGs, but it was like with respect to national and international levels and what are the challenges. It was really informative and lot of contents were there. So it was really a pleasure to listen you. Thank you so much, sir.
and
So
sir has
since
got
this,
one more question. Sir has got
since
one more
this,
question.
yes, sir. So since this is a theory session, it was a little bit boring, but one more technical session is there. Maybe on Saturday, I think on Saturday.
Yes.
We'll meet during that session.
Yes, sir.
Thank you, sir.
Looking
Thank you
forward,
so
looking
much
forward to it.
for DOIP College for giving me this opportunity, and organizing team, the principal, sir, and participants for patient listening. Thank you so much.
Thank you. Thank you. Good night, sir. Good night.
Thank you, sir. Good night, all.
Good night.
We should thank the participants also.
Yeah, thank you. Thank you all for attending the session. And good night. See you tomorrow.
At 6 p.m.
Uh,
At 6 p.m. sharp.
yeah, at 6 p.m. sharp. Thank you so much for attending. Thank you so much, sir, for that.
Tomorrow you have got more interesting because our Pro Vice Chancellor Madam is speaking, and that will be more academically connected also. I think they'll appreciate the sessions tomorrow.
Yes.
Good night, madam.
Good night. Thank you so much.